So now that we have another identity, our sum and difference identities, we can use them to prove other equations or other identities. So we're going to prove our cofunction identity because that's our basic one for cosine. So remember, cosine is called that because of the complementary angles the two angles make for sine and cosine when they're equal. So we can use cosine and its sum and difference identity to prove the left side. So this would be cosine of 90 degrees, cosine of u. Remember, cosine is selfish. So we then change the sign, and now it's sine's turn. Sine of 90 degrees, sine of u. And if you remember, cosine of 90 degrees is 0, and sine of 90 degrees is 1. So that would become 0 plus sine of u, which is sine of u. And yes, these are proofs. So I need to see each step just like before. So this one right here has been transformed to identity. We are then changing this. We can't just say, oh, well, this is 0 and this one is sine. You've got to show each one at a time through your proof. And so now we have shown that the right side, the left side, is equal to the right side. All right, let's try another one. Just ignore the right and left. They're backwards, obviously. So we end up with cosine of x minus pi. And so this would be cosine x, cosine pi. But now we put a plus, and it's sine's turn. So if you remember, pi is all the way over to the other side. So cosine of pi would be -1. And sine of pi would be 0. So we end up with negative cosine x plus 0, which is negative cosine of x. The same. All right. Let me have you try one now. So here is tangent of x minus pi. And so you're going to use the tangent one, and I will get you started. So this is tangent x plus tangent pi, and then 1 plus. Remember, tangent is the parent, and so if cosine's a control freak, tangent's a super control freak. That's where they learned it. This is tangent x, tangent pi. I'm going to put the parentheses just because I like them right now. So now you just need to simplify this into tangent x. Hit pause and try it. Okay, so this is what you should have. So tangent pi was 0, so plugging those in. You still need to write it, and we can't just go, oh, well, this is tangent x. There's got to be a pattern to each one thing at a time. So we converted tangent pi into 0. We converted tangent pi into 0. And then 0 times tangent x would be 0. And then 1 plus 0 is 1. That one I'm fine with just skipping all the way over here because it's purely computational. All right, let's move on now to something a little more fun. I was going to say difficult, but no, they're fun. These are puzzles. You got to think of them as puzzles. And so whenever you see this plus inside or minus inside of a sine or a cosine, you immediately think sine and cosine, sum and difference. So if we take our left side, and we go, okay, well, that's a sum and difference, and that's a sum and difference for sine and cosine, and we write them out. Minus. I'm going to put the sign underneath it, just because I'm out of room. Put a little plus sign here. We get sine x cosine pi over 3 minus cosine x sine pi over 3. Now all we have to do is a little simplifying, and we should end up with 0. Okay, so cosine of pi over 6, remember it gets bigger as it goes. So cosine of pi over 6 is rad 3 over 2. And sine of pi over 6 is 1/2. Because it gets bigger as it goes through. Plus, and then cosine of pi over 3, it's getting smaller. So that one is now the 1/2 sine x. See how they're matching up perfectly? I can already say, oh, you're gone. And move on to the next one now. So sine of pi over 3, we already know then will be rad 3 over 2. Because again, it gets bigger. And that one cancels. And so I'm not going to make you put these together and say, okay, well, that one's 0 and that one's 0. We already know it's all 0. We're done. That's it. So this is all you're doing is you're expanding them out and putting them together. So there are 2 for you to try. Okay, you get to pick which side. So obviously you always want to pick the worst side. This one will work to get back here, but look at this. This has already got the sum and difference. So there should be a way that you know which side to pick. And if you pick the wrong one, guess what? You stop and use the other side. All right, so I want you to try this one. Hit pause, try these 2, and then unpause it, and then check your work. All right, so hit pause now. So here we go. So again, make sure you show all the expanding. Those should have canceled. And then we know that these 2 are 2. But you don't want to just jump from here to here. Make sure you take as many steps as possible so that you don't get a word that's written on your test called why. Why does that work? So if you had this and then all of a sudden you went from here to here, that's a huge jump. Now, can you do it mentally? Yes, but these are proofs. You're supposed to be showing me each step to prove it's true. So this we know is true because cosine x plus y is equal to cosine x, cosine y, sine x, sine y with a minus. And then we know that we can divide them both separately because it's this and this both being divided by this. That we know cancels to 1. If we split these up, we can then see tangent. But you need to see the tangent x is this, the tangent y is this. Every step has to be shown. I know it's tedious, but it's getting used to our proofs. Just like you did in geometry, you had to show every single reason for every single thing. All right, here's some more that we're going to do together just because they're fun. So if we take that same cosine x plus y, and this time we're now going to multiply them. So before we've been adding them. So when we multiply them, you want to put brackets. Put them right in the middle like that. And then you expand them out. Making sure you change them. And you're not going to have to multiply these because once you see a minus and a plus like that, we have our difference of squares. You see the cosine x, y, sine x, sine y, sine x, sine y with a plus and a minus. So we're going to end up with cosine x, cosine y squared minus sine x, sine y squared. And there's no plus in here. This is just distributing the square, which gives us cosine squared x, cosine squared y, minus sine squared x, sine squared y. And you're like, oh crap, that's not the same. So how do we get there? These are now Pythagorean identities. So over here, we want this to be a cosine x. See it? So who needs to go? So there is no cosine y. This one needs to go. And there is no sine x squared. So that one needs to go. So we're going to use those. So this one has to stay, and this one has to stay. We need these. So how are we going to do that? We're going to replace the ones that we don't want. So this is now 1 minus sine squared y. And see, now we have a sine squared y again. And this is 1 minus cosine squared x, which is the other one we want. So if we do a little distributing, we end up with cosine squared x minus cosine squared sine squared y. And then you start getting a little excited because there's our cosine squared x, and our cosine squared x sine squared y is going to appear here again. So a quick little trick is this minus. We put a plus here and bring it inside. So I'm going to put a plus so we can see it like that. And then that way we have our signs. So that's now a minus 1. So we end up with minus sine squared y. And see, so far, let's make that a green or a blue. That and that are exactly what we want. So this next step should give us something that cancels. I'm going to put the cosine first. And so see, they're the same. They cancel. That's the next step. And we end up with cosine squared x minus sine squared y. Now I have left side here, but I ran out of room. So we're just going to put it there. There we go. We just proved it. So see, it's just like the other identities we've been doing. You're just plugging stuff in. So when you see an identity, simplify it out and multiply it. When you see your difference of squares right here, you put it in its form. Every single time you see cosine squared and sine squared, you can use a Pythagorean identity. It's just a lot of replacing over and over again. Now here's my favorite. We don't really see them as sum and difference between 2, but you can do a sum and difference between 3. What you have to do is group them. And so it doesn't matter which 2 you group. So we're going to group these 2 together. And we end up with sine x cosine y plus z plus cosine x sine y plus z. And then now we have another sum or difference identity. So sine x bracket. And we get cosine, our selfish guy. Oops. Minus. See, now you're probably really good at the identities and being able to just plug them in quickly. So we're going to have to come down here on the other side as well. Cosine x. And so this would be sine y, our sharer. So we leave it alone. And we distribute, and it should give us our each one. So there's our sine x, cosine y, cosine z. Sine x, cosine y, cosine z. So we just have to distribute to get all 4 terms. Sine x, cosine y, cosine z, minus sine x, sine y, sine z. And then the next one, cosine x, sine y, cosine z. That was not a sigh of frustration. That was just a sigh of relaxation. Because these are just relaxing. They're little puzzles, like a Rubik's Cube. You get to work them out. And then we check our 4 terms. So we have, we have this one. Cosine x, sine y, cosine z. Cosine x, sine y, cosine z. Cosine x, cosine y, sine z. And then sine x, sine y, sine z right there. Check. I'm not going to make you write it over here as well. Therefore, we're done. So when you see 3, 4, 5, it doesn't matter. You just pair them up into where there's 2. And then once you have them in sets of 2. So you could have 4. You'd pair the first 2, pair the second 2, and then expand. All right. So this one is one of those where you don't really see what's going on. And they're going to throw them in because you get in this habit of just seeing sum and difference, sum and difference, sum and difference. So they're going to start throwing in other problems like this as well that are just review as before. So it doesn't really matter which side you pick here. We want to either take the cotangent and turn it into cosine over sine, or the cosecant and turn it into sine over sine. So to 1 over sine. So it's up to you on what you want to do. I'm going to pick with the cosine x. Start with the cosine x, cotangent x, because I know with this one I'm going to have to add them with a fraction, and it's fine. It's not going to be difficult, but I know this one is just a quick change. So we end up with cosine squared x over sine x. And that goes back to our Pythagorean identity. So we can go 1 minus sine squared x over sine x, and then divide. And we end up with cosecant x minus sine x. So they're going to give you some in this section that do not have a sum or difference property attached to them. You don't have to apply the sum or difference. It's only if it's given to you. So when you see it like that with an addition of angles, then you use it. And when you don't, just go back to our reciprocal identities and ratio identities. All right, thank you.